Hello everyone. Today we are going to discuss a new topic, and today's topic is called quadrilaterals. Now I know you all might have been familiar with this term called quadrilaterals. You might have heard it earlier. So we'll be discussing today what is a quadrilateral, what are the different types, how they differ from each other. All these things we'll be discussing, as well as there are some of the properties also we'll be discussing. So let us begin with what are quadrilaterals. So a quadrilateral is a polygon which has four sides, four angles and four vertices. So we all know what is a polygon. So in this polygon there are four sides, four angles as well as four vertices. Now let me show you the diagram of a quadrilateral. So you can see here ABCD is a quadrilateral. Here there are four sides, AB, BC, CD and DA. Four angles, angle A, angle B, angle C and angle D. As well as four vertices. These are the vertices, the meeting points of the sides. So point A, point B, point C and point D are the four vertices of the quadrilateral. Clear? Now next, the sum of all the four angles of the quadrilateral is equal to 360 degree. This is one of the property of a quadrilateral, which is said as the angle sum property of a quadrilateral, that whenever we add all these four angles, angle A plus angle B plus angle C plus angle D, the resulting angle would be equal to, or the resulting sum would be equal to 360 degree. Whatever the angle may be, but whenever we take the sum of all these four angles, the result is always 360 degree. Now next, some of the examples of a quadrilateral are rectangle, square, parallelogram, rhombus, trapezium. These are also some of the types of quadrilateral, you can say. And all these types we'll be discussing today in this topic, one after one. So let us see what are these types. So the first type that we'll be discussing today is a rectangle. Now, since from the small class itself we all know what is a rectangle, the definition of a rectangle. So let us begin with that first. A quadrilateral whose all the four angles are equal and the lengths of their opposite sides are equal is called a rectangle. Now in this chapter or in this topic, according to your textbook, the diagram is made, you can say, not drawn, you can say made with the help of something called the set squares. So there are two pairs of set square that is available in every geometry box. You might have seen it in your geometry box. These are triangular in shape and the angles vary of both the types. One is 30 degree and 90 degree. Sorry, one is 30 degree, 60 degree and 90 degree, and the other one is, that is a longer one, a little bit longer, and the other one is 45 degree and 90 degree. So there are two pairs of, you can say, or two sets of set squares available in your geometry box. They are triangular in shape. So if you don't know about them, then you can check your geometry box. So with the help of set squares, we'll be explaining this topic. So say for example, we take two set squares of the dimension. This is 30 degree, sorry, this is 60 degree, this is 30 degree and this is 90 degree. So if we take a set square of this dimension, that is 30, 60 and 90 degree, 2, okay, we'll take 2. And then we arrange them in this way, one upon the other, and whatever resulting figure that we get is a rectangle. And according to the definition, if you see, all these angles are equal, and that are equal to what? 90 degree. So that is a right angle. And the lengths of the opposite sides, this side and this side are opposite, this side and this side are opposite, and their lengths will be same. Clear? Now, the diagonals of a rectangle are of equal length and bisect each other. Now, what are diagonals? This thing over here, the blue line, if you see where it is joined, this is one of the diagonal, connecting one vertex to the other opposite vertex. Here also if you draw, although it is not drawn here, but if you draw a line from here to here, from this vertex to the other opposite vertex, that line will also be called as a diagonal. So in a rectangle there are two diagonals and both these diagonals are of equal length. First thing. And next thing is that they bisect each other. Bisect means they cut each other in such a way that this half and this half will be equal and this half and this half will be equal. Wherever it will cut, say here if there is the point of intersection, from this point to the here it will be of equal length, and from this point till here it will be of equal length. Similarly over this side and over this side also the lengths will be of equal. So we can say that they bisect each other. Now next, moving on to the next quadrilateral, that is square. So first of all, as usual, the definition: a quadrilateral whose all the four angles are equal and also the lengths of all the sides are equal is called a square. Here also we'll be showing you the diagram with the help of a set square. So here the pair of set square is of the dimension 45 degree, 45 degree and 90 degree. So we take two such set squares and then we'll be discussing the definition. First of all, here four angles are equal, same like rectangle, they are of 90 degree each, and also all the four sides are equal. This side, this side, this side, whichever side you take, the lengths of all the four sides are equal. Now next thing, a square is a rectangle with equal sides. Yes, as I have said earlier, it is a rectangle only, but here only the difference from a rectangle is that it is of equal lengths of all the four sides. This is the only difference. Next thing, a square has all the properties of a rectangle. So already we have discussed a while ago about the rectangles. So that same thing applies in the case of a square. Next is, in a square the diagonals bisect each other. Same thing just like a rectangle. But here one more added feature is there, that all are of equal length, and this is also same, the diagonals are of equal length just like a rectangle, but also they bisect each other. But the thing is that they are perpendicular bisectors. Now what is perpendicular bisector is that just like a rectangle they are of equal length, clear, they also bisect each other, this part is also clear. And while bisecting, the angle that is made by these two diagonals at this point of intersection, that angle is 90 degree. So in that case, the bisectors have a particular name. They are called perpendicular bisectors. If the angle made by their bisection is 90 degree, then it is called a perpendicular bisector. Clear? Now next type is parallelogram. By the name itself, something comes in our mind, something related to parallel, which are parallel. So the definition also says that a quadrilateral whose opposite sides are parallel is known as a parallelogram. Here also we will be using the set square of the type 60 degree, 30 degree and 90 degree. So we'll take two on the opposite sides in this way. So here if you see, this side and this side are opposite sides and they are parallel, and this side and this side are opposite sides and they are also parallel. So it is a parallelogram. Now the opposite sides of a parallelogram are of equal length. Yes, this side and this side are equal, just like a rectangle, the opposite sides are equal length. Now next is, the opposite angles of a parallelogram are of equal measure. Here all the angles are of not equal measure, only the opposite angles. This angle and this angle are of equal measure, and this angle and this angle will be of equal measure. Next thing, the adjacent angles in a parallelogram are supplementary. Adjacent means this angle and this angle are adjacent. This angle and this angle are adjacent. This angle and this angle are adjacent, and these are adjacent. Adjacent means the neighboring, just the next one. So if we take both the neighboring angles or the adjacent angles, then their sum will be supplementary. Supplementary means 180 degree. This angle and this angle, if we add, it will be equal to 180 degree. Say for example, here it is 60 degree and this angle is 120 degree. So this plus this will be 180 degree. So that is supplementary. Now next, the diagonals of a parallelogram bisect each other at the point of intersection. Yes, here also the diagonals bisect each other. Although here the diagonals may not be of equal length. Clear? Depending upon how you draw it. But yes, in general case, you can say that the diagonals bisect each other, or you can also say that the diagonals are of equal length. So you can try it out for yourself and check for yourself now. It would be a fun activity for you, that whether the diagonals are of equal length or not. You can try to draw a parallelogram. This would be a homework for you. So you can try it out for yourself and check. Although the diagonals bisect each other, does the diagonals are of equal length? You can check it out for yourself. Now next thing is a rhombus. There is also one more type, a rhombus. So a quadrilateral whose all the sides are of equal length. So this sounds kind of similar to the square case, you can say. So you can see here we have used 4 set square, 1, 2, 3, 4 of the order, same thing, 30, 90 and 60. So if we put such 4 set squares in such a way, then here you can see all the length of all the 4 sides are equal. But yes, here again the angles of all the 4 angles, you can say, are not equal. The opposite angles are equal here. It has all the properties of a parallelogram. Yes, they are parallel, obviously. They are all equal. Only this thing is a little bit different. And then the diagonals bisect each other, obviously. And they are also perpendicular bisectors. Now the last one, or the last quadrilateral that we'll be discussing, as given in your textbook, is a trapezium. So what is a trapezium? A quadrilateral with a pair of parallel sides is known as a trapezium. Here only one pair of parallel sides, not both the pair. In parallelogram or in rhombus, we have seen that there are 2 pairs of parallel sides. Say for example this and this, and this and this. So there are 2 pairs. But here in a trapezium there is only 1 pair. So let us see which is this. So if we will use 3 set squares instead of 4 of a similar kind, and we'll arrange this in this way, then if you see here carefully, only this top and the bottom sides are parallel, but whereas this and these sides are non-parallel. So in such a case, a quadrilateral is called as a trapezium. Now here you might be thinking about the bisectors or the perpendicular or the, you can say, diagonals. No, in this case, in case of a trapezium, the diagonals won't be possible, and even if it is possible, they are not of equal lengths, neither they bisect each other, neither they are perpendicular bisectors. So here we won't be dealing with the diagonal factor. So that's it for today's class then. I hope you all have understood the different kinds of quadrilaterals, how these quadrilaterals differ from each other, and what are their similarities as well. So you can tabulate it down in a table. It is already given in your textbook. If you see it carefully, and there is a table given. So if you can fill up the table, then you would have find that what is the difference among them and what are the similarities among them. So that's it for then today. Thank you and have a nice day.